So we're going to be starting with functions, is chapter 6. And these are the topics that we're going to be covering. We're going to start with some definitions, modular programming, how to call a function, how to define a function, some prototypes, what is a prototype, which is a model, how to send data into a function. And there are two different ways. One way is by sending it by value, and the other one is by sending it by reference. And we're going to be doing that. How to retrieve data from a function, and we can only retrieve one value, and it's going to be through the return. The different data types that we're going to be able to return, if it's going to be a floating point number, if it's going to be an integer, if it's going to be a character, if it's going to be a Boolean. One of the applications is a function is using menus. We're going to work a little bit more with the scope of the variables, the difference between local and global variables, and it's going to be, I think, more easy to understand this time because of the function concept. We're going to be working with overloading functions and how to integrate functions, and the two terms that are used in programming is stubs and drivers. So we're going to go through every single section in this chapter. It's a very important chapter because it is going to have the basics for everything else that we're going to be covering during the semester. So we're going to start with a brief introduction, and I already started with this last class. What is modular programming? What is modular programming? And modular programming is breaking a program into smaller, more manageable, and we can call them functions or modules. So instead of writing one program or the complete program, what we're going to do is we're going to break it into smaller units so that it can be easy to code, easy to maintain. We're going to see that it's going to be faster. The time that we're going to be spending coding is going to be reduced, so that is also an advantage. Another advantage of using this function or modules is the reusability. The reusability. I can create a function that is just going to say, thank you for using this program, see you next time, and I can apply it to different programs. Okay? By just calling, not even copying the code, but calling, okay? Calling that function where we have all that code. Okay? So we're going to see that. So this type of programming supports the approach divide and conquer. That's what we are going to be doing. So instead of asking one programmer to complete the whole task, we're going to break it down into smaller tasks, and we're going to assign it to different programmers. Like I can think of one application right now. They asked me to create a payroll program where I have to calculate the gross pay of the employee, right? I have to calculate all the deductions and subtract them from that gross pay. That is going to give me a net pay, but then I have to display that information or print the check. So what I do is I was assigned that project. So I know that it will take me maybe a month to do it. But if I break it down into smaller units and I can assign Ivan one part, you can do the calculation of the gross pay. Concentrate on that. Give me that set of instructions. Then, okay, you're going to be doing the deductions. You have to do that. And then you're going to be concentrating on printing that information or displaying that information, printing the check. And I'm just going to be doing the main. So main is going to be asking you to do the gross pay, Ivan. Main is going to be asking Roque to do the deductions, and main is going to be asking Juan to print. So now the four of us are going to be doing this task, and it's going to be much faster. The task is going to be less, right? And we're going to be integrating everything together. But there are some rules that we need to follow. We need to get together and decide on some layout so that we can all integrate those 3 functions that we're going to have, or 3 modules, plus main. So this is what we're going to be learning. We already know how to program in C++, so now what we need to do is just set up those rules. Set up those rules. How are we going to be working? Because we're going to work with functions from now on. So first I need to decide, how am I going to be calling? Okay. When I am working with functions, I need to call the function. I'm main, so I have to ask the gross pay function to come in and do the job. So that requires a function call. So that is a statement that causes a function to execute. Okay, we have to remember that. We always need a function call. I can have all the functions there, but if I don't call them, they're not going to execute. Function definition are the actual statements that make up the function. Okay, I call the function, but is there a definition there? Did Ivan do its job? Or not? So I need the definition there. So what do we have in the definition? It's going to include a name. That's the first thing. It's going to need a parameter list. It's going to need a body, and it's going to need a return type. Let me give you an example here. I'm going to try to work with my mouse. So let's suppose that we have here the payroll main, right? Here is main. And I have somewhere in the server, okay, this is in another section, I have one section where we have the gross pay. And I have all the instructions here. I have another section where I have my deductions. And I have all the statements here. I have another small function that is the one that prints. And I have all the instructions here. So what I need is to call from main. I'm going to be calling on gross pay. Do the gross pay. So main is going to go and find gross pay, execute all the instructions. When it's done, it's going to return. It's very smart. Okay, it's going to return, and it's going to continue with the next statement in main. Let's suppose that we have a couple of statements here, C outs or C ins or whatever, and then I have to call another function again. So I'm going to be calling deductions. So with deductions, I go to the function, do all the instructions here, get to the end, and then come back. Then continue with the next line underneath that one in main, and it's going to be print. So, and it's going to be the same thing. We're going to go to this call is going to be sending control to print. It's going to find it somewhere where it is, in the server, in the hard disk, wherever it is. Do all the instructions there, hit the end, and then come back. And continue down here, whatever that is, in main. So I have maybe 4 programmers here working. One in main, another one doing the gross pay, another one doing the deductions, and another one doing the printing. I have a call and I have a definition. For the definition, this is what we need. We need a name, we need a parameter list, we need a body, and we need a return type. What are they? The name is what is going to identify the function, both the call and the function itself. This is called GP, so I know that the one that is going to be answering is going to be GP, right? That's why it has a name. So the names, they must match. The other function, the deductions, we call it D, so I know that the one that is going to answer is going to be D when I call it. I call D and you answer. I call P for printing and that one is going to be answering. So the name is very important here. Function names follow the same rules as variables. So when we name it, we need to follow those rules. Remember the rules for naming variables? Can we use letters when we're naming variables? Yes, letters. Can we use numbers when naming variables? We can use them, except that we cannot start the name with a number, right? Can we use special symbols? No, we cannot use special symbols. I cannot use a question mark. I cannot use an exclamation mark, except what can I use? There's one that I can use. The underscore. Can I use a space in naming variables? No. So those rules we need to remember, because those are the same rules that are going to apply when I create a function name. The parameter list, it's sometimes I need to send something to the function so that it can work. Like in this example, to calculate the gross pay, what do I need to give this function? What do you think we need? To calculate a gross pay, what do you usually need? The hours that the employee worked and the net and the hourly rate, right? We need that to send it so that they can do the calculation. So I'm going to be sending this one that is going to be calling. I have to send it to send this function two items, two values, hours worked and hourly rate. So when I send something, this guy that is going to be receiving this function is going to need a parameter list and is going to need variables that hold the values passed to the function. And those values are going to be placed, or variables are going to be placed within parentheses. Of course, we need a body, and the body is going to be surrounded by curly braces. And we also need a return type if we're going to be sending something back. Okay, let's see in our example right here. Gross pay. We're going to be sending to gross pay two things, right? So this one is going to be receiving hours and is going to be receiving rate. It's going to be doing the calculation right here. And then when it goes back, remember we have a line right here that it goes back. It's going to be sending back the result, right, of that probably multiplication. So it has to send something back. So we're going to be also adding a return type. What are you going to be returning? Type. It refers to the data type. Like in this case, what data type do you think we need here? If we're going to be sending the multiplication of hours times hourly rate. A double. Why a double? Because we're going to be paying, it's dollars and cents, right? So it's a floating point value. So we want a double or a float or a long double. Okay, let's suppose this example that what my function is going to be assigning a letter grade. A letter grade. So what do you think is going to be the data type? A character, a chart. So we need to put it there. So we're going to need all this in the function definition. So we have a call and we have a function definition. Here's an example using main. Main has, here is the return type. So that is going to be on the first line. Here's the name, and here's where the parameter list is supposed to be. Right now it's empty. It has an open and a closed parenthesis. There is nothing in it. So main does not receive values, and that is correct. And main always returns an integer. And this line is the one that is going to be sending this value. Think of this data type as a channel, as a highway, where this 0, it has to go. So if I have, instead of int, let's suppose that I have char, like the example that I asked you right now. Then the return has to be a letter. I can return an A. And this is correct because this is the highway, remember? So the A can go through this highway that I already specified that can only take letters. If I put a double here, remember I'm saying, so I can return a 4.5. So this 4.5 can go in the highway, right? Because it's a double. So the return type is going to indicate what I'm going to be sending back. If I have a double here and I try to send the letter A, this is not going to work. The highway is going to close. And there's going to be an error. So this is my program definition. So the first thing that I have in my program definition is the top line, and we call that line the header. It's going to consist of the return type. We already explained that. Here it is. Okay, int. It's going to consist of the name. We already talked about the naming and how important it is that they have a match. And we follow the rules for variable naming. And we also have a parameter list. So I ask you, if I'm going to be returning a floating point number, you can use float, you can use double, you can use long double. If we're going to be sending an integer, we can use short, we can use int, we can use long. If we're going to be sending a letter, like the letter grade, we can use chart. If we're going to be sending just return true or return false, what can we use? Boolean, B-O-O-L, right? But sometimes the functions, they don't return. They don't return a value. It can be just like the printing something, like in the example that I gave you, the printing. This one doesn't need to return anything. It's just going to be printing the check. So when that happens, what we're going to be using as the return type is going to be void. This word, void. If a function does not return a value, its return type is going to be void. But all the headers, they require a return type. It can be a character, it can be a boolean, it can be a short, it can be an int, it can be a long, it can be a float, a double, or a long double, or void. But we always need those three things. I need the return type, so that is the first thing. I need the name, that is going to be the second thing, and then the parameter list. So the name is here. The return type is going to, no return type is going to be void. And no parameters is going to be parentheses and parentheses, open and close. and that is what we call the header. It needs those three things, always, okay? We cannot define a function if we don't have those three things. In addition to that, we need the body of the function. And the body of the function is going to be enclosed in our curly braces. So underneath this header, we're going to open a curly brace, and the end of the function is going to be marked by the closing curly brace. Okay? Yes? Yes, of course. Right here in main. Let me just remove all this. Here we go. What do you see underneath the header? This is the header, right? It has the return type, it has the name, and it has the parameter. And then right after it, it has what? The curly braces. If we omit one of them, our program is going to run? No. So this is what we're going to find in every single function. And the body is the instructions. Right here we have another. Here is the function. Void is the return type. Print heading is the name. This is the parenthesis to enclose the parameter list, and then here is the body. And the body only has one statement. Yes. Okay, because remember now the example that I gave you. They asked me to create a payroll program. To create a payroll program, to solve that problem, I have to calculate the gross pay, I have to calculate the deductions, and I have to display the net pay, right? But instead of doing it doing it by myself, I'm going to hire these 3 programmers that I have, and programmer A is going to be doing the gross pay, so I assign that task. So it's going to be one function. The other programmer is going to be doing the second function, which is going to be calculate the deductions. So it's going to be smaller tasks, right? It's just going to concentrate on, okay, I have to calculate the Social Security number based on the gross pay that the employee had, right? And then the other another programmer is going to be doing the printing. Okay, so I have to print the check, or but I'm going to be printing the gross pay and the deductions and then the net pay. So the one that's doing the printing will do that? It's just yes, it's just going to be doing C outs. Okay, so what the program is doing the printing will be doing that. Exactly. So the main is going to be calling, hey, print. Where's my function that prints? Right here. So right here I only have C outs. And my programmer, that's all is going to be concentrating on. So you specialize in printing. So it's going to have all the little asterisks and hyphens and put it in a box, etc., etc. Any other question? Okay, let me show you a couple of programs. Here we have, this is, right now we're going to see that we're going to put everything together, but I want you to visualize that the function and that we're going to be using in main, they're going to be in two different locations. Two different locations. But for right now, we're going to do it as if it was in one program. So compiler always goes directly to main. So we start, we're the compiler, so we start line number 1, we skip it because it's a comment. Line number 2 includes, so we bring this file, right? IO stream with all the code that we need so we can work it out. And we go directly to main. In main, let me just open it up so we can see it better. In main, line number 17, this is where we start. This is the entry point. Line number 18, we have the curly brace. Line number 19, we say, hello from main. So we're sending that message. It's just an indication I am in main. Then we have in line number 20, we have a call right here. We're calling display message. This is the way that we call. We call by giving a name and then the parentheses. So this means go and find display message. That's what it is. So this is line number 20. Where do we have display message? Give me the line number. 9. Line number 9. Here is the header. Remember, it has void. What is void? What is this? It's a return type. What is this telling us? Because we're the compiler. It's not going to return a value. Then here's the match, display message. Display message. Here's the call. So I know that I'm here. Then open and close parentheses. What is this telling me? No parameters. So I did not receive anything. I don't need anything. I meaning display message function. So display message function is going to do cout, hello from the function display message. End of the function, right? Right here. And where is it going to go to? I didn't hear, I'm sorry. Back to main. Where main? Okay, it's going to go to line number 20. It says, hey, I'm done. So it's going to now continue with line number 21, and it's going to say, hello, back in function main again. So what did this program display? Exactly. It has 3 messages. Hello from main, hello from function display message, and then back in function main again. So do you see how we're moving to a function and then coming back? We started on line number 17. We are the computer, right? So we start in line number 17. Then we go line number 18. Okay, this is a body. Line number 19, display. Line number 20, call. So where is it? It's over here. On line number 9, we start. Line number 10, line number 11, we display a message. Line number 12, we go back. Where to? Line number 20, we check that we are done. We continue with the next line, 21, and then 22, and we end the program. This part right now, all this, it's inside our same program. But when we are in a real environment, we're not going to have it there. It's going to be maybe in a USB, in an external hard disk, in the server, in another location. Okay, we're going to open another program, program 2. These programs, they are in your textbook. Okay, they are there in the e-text. Program 2, this function, okay, this function displays a message that is in a loop. Just so that we can see it better, I'm going to have here again, so we go directly into main. Line number 17. 18, remember we are playing computer, so we're acting as the computer. Number 19, see out. Hello from main, so we display that message. Then line number 21, for int count is assigned the value of 0. Count less than 3, count plus plus. Okay, I know, I'm the computer, I'm very smart, I know that this is a loop, right? And I start by setting 0 into count. And then by checking, is count less than 3? It is. So what do we do? We're the computer. What do we do? Where do we go to? Line numbers. Give me the line numbers. We go to line number 22. If this is true, we go inside the loop, right? So line number 22 is the body of the loop, or the block of the loop. Line number 23, we have what? Display message. What is this? It's a call. So we're calling this function. Where do we have this function? Line number 9. So this is going to send back, to send control to line number 9. Display message, no parameter, so I'm not sending anything, and we're going to be displaying hello from function display message. We're done in line number 12, and now where do we go? What line? 23. 23, we finished. We need to make sure that we're done with this line, and then we go to line number 24. This is the end of a block for a loop. So that means I have to go back to the loop, which is line number 21. We increment the value of count by 1. Now, count was 0 plus 1 is 1. Is 1 less than a 3? It is. So we go back in the loop. Line number 22, line number 23. And we have what? It's a function call. So where are we going now? Back to 9. So this is the second time that we're calling this function. Display message. So we go into the body of the function. We say, we display hello from the function display message. End of the function, line number 12. And now where do we go to? Back to 23. We're done. So we continue with the next line, 24. This is the end of the block for the 4. So we go back to number 21. We add 1 to count. It was 1. 1 plus 1 is 2. Is 2 less than a 3? It is. So we go back into the body or the block of the 4. Line number 22. Line number 23. Again, what do we have? A call. And we're sending back control to 9. We display the message again. Hit the end of the function. And then we come back to number 23. 24, go back to number 21, and we add 1 to count. It was 2 plus 1 is 3. Is 3 less than a 3? No. Where do we go to now? Louder the number, please.
2 is still less than a 3.
No. 2 plus 1. We had a 2 plus 1 is 3. 3 is less than a 3? So where do we go? 25. So we go to line 25, and we say back in function main again, and we end. What did we display?
Hello from main, hello from function display message, and then back in function.
Exactly. Hello from main, hello from function display message 3 times. We repeat the message 3 times, and then we end. So here they are showing us how in the first program we call the function once. Now we're calling the function 3 times. If I want to call the function 10 times, I'm going to change this to a 10. If I want to call the function 1,000 times, I'm going to put here 1,000. Right? And every time is going to be displaying back in function.
Does it matter where the void display message is, or is it always going to go with function?
It has to be before. Because the linker is going to check that everything is there. Remember, the linker is the one that checks that all the resources are there. But we're going to change this, and we're going to be using something that is called prototype, so that we don't have to have the function before main. We're going to put it somewhere else. Okay, I'm going to open another one. This function has, this program has 3 functions: main, first, and second. So we go directly, we're the computer again, and we go directly to main. Line number 26. And we have line number 27, line number 28, see out. I'm starting in function main. Line number 29, what do we have? What is this line? It's a call. So we're calling. Where do we go from here? Line number 9. And here, first, we're going to go into the body and we're going to display, I'm now inside function first. Hit the end of the function, line number 12, and where do we go to? Back to 29, we check that is the end. We don't need to do anything else, so we continue with the next one, and it's 30, and it's going to be called the second. It's a function that is called second. Where do we go to now? To 18. Then here we have the body. We display, I'm now inside function second. Hit the end, and then back to 30. This, I don't need to do anything else. Go to 31, back in function main again, and we close the program. So now what did we display? I am in main. I am in function first. I am now inside function second. And I'm in function main again. Will it make a difference if I change this? Yes, I'm asking, will it, I have my output, will it be different? Yes, no, maybe? Why? What is it going to display now? I'm starting in function main will be my first message. I'm now inside function second will be my second message, right? I'm now in function first will be my third message, and now I'm back in function main will be my last message. Okay, the same thing. I'm going to change this. Oh, let's see. I'm going to remove this one, this call. What am I going to have now as my output? what will be the first message? I'm starting in function main. Second message, I'm now inside function first. Third message, back in function main again. And my last message, I'm now inside function second. Questions about this? Right now we have been calling from main, right? But we can also call from another function. This program has 3 functions: main, deep, and deeper. So again, we're going to play computer. So we start on line number 28, main. Here's my body, and I'm going to be displaying. I'm starting in function main. So we display that. Line number 31. This is a call. We're calling the function called deep. Do we have somewhere a function called deep? Yes. Line number 18. So we go to line number 18, deep. Here's the body, 19. And then we say, I'm now inside the function deep. Line number 21, what do we have here? A call. Now we're going to be calling another function that is called deeper. So do we have something called deeper somewhere? Yes. Number 9. So from here, from line number 21, we're going to go back to line number 9. And we're going to say, okay, here's deeper. What do I do here? I'm now inside the function deeper. Display that. And then go back. Where do I go to? After 12, what do I do? Line number 21. So we go to line 21. This is it. I'm done with this line. So I continue with line number 22. Now I'm back in deep. Line number 23. And where do I go to now? To line 31. And then we continue line 32. See out. Whoever called me, I always have like that link. And I always remember. I always remember that who made the call. I'm going to add another function here. Void deeper. Okay, so let's see how this is going to work now. Okay, this has to go before. Okay, I have to put it before, so I'm going to cut it and put it before. Before it's being called, I have to declare it so that the linker knows where everything is. So we start on line number 35. We go line number 36, 37. I'm starting the function main. and then we call deep. Line number 38 is going to go back to line number 23, right? And we're going to indicate here, I am now inside the function deep. And this is going to be calling deeper. Number 26, where is deeper? It's here, a 9. And we're going to display, I'm now inside function deeper. Okay, line number 12, that means go back. Who made the call? Right here. Remember, it always has that string. It's not like I send you there and you never come back. No, we have something that is going to pull you back because I call you. So from here, we're calling now deeper. I'm in line 27 and I jump to what line? 18. So 18 is going to display I cannot get out. Line 21, and where do we go to? 27. So 27 now goes to 28. I'm back in deep. Line number 29, and now where do I go to? Where to? 38. 38. Okay, remember I was jumping here back and forth, and this in deep, deeper, and deeper, right? Moving back and forth, but I have to, at one point, I have to go back to whoever called me. And in this case, it was the first one that started the call was main. So I'm going back to main somewhere, somehow, but I will do it. So now we're on number 39, back in function main again, and we end with in line 40. Questions? Okay? No questions? Okay, so we will continue. Main is automatically called when the program starts. Okay, so we don't need a call for main. Main can call any number of functions. We already saw that. We did call one function, and then we call the same function in a loop. So we repeat that call, and then we call another function, and then from that deep, we call deeper and deeper, right? So again, functions can call other functions. Now, the examples that I was giving you, we had all the functions were listed before main. And even the deeper, I had to list it before it was called, before the deep. I had to put it before. And I already explained why. The linker is going to make sure that all the resources are there. So before the call is made, it has to be defined. The definition must be there. But there's a way to bypass that. Because in the first example that I gave you about the payroll, well, they're going to be doing their own function. And I am main. I have to do something. I have to start working with something. So I have to set up the rules. So I'm going to be doing like a model, and we call this the prototype, where we're going to be setting up the way that the real thing is going to be. Like if I'm going to, they asked me to build a mall, a new mall here in Bronzeville. So before I start putting everything down, actually building it, I'm going to create a prototype, a model of the mall, and I'm going to present it, and it's going to even have the little trees and everything, the benches and everything, and little people and cars moving into the mall, right? So that they can see, okay, it's going to be a 2-story mall, and it's going to be a small thing, right? But it's going to have the representation of everything that is going to be in that big mall that I'm going to be building. So that's what the prototype is. So we're going to be giving to the compiler a prototype of the function that Ivan is going to be creating. I'm going to give a prototype of the function that Roque is going to be creating, and I'm going to give a prototype of the function that Juan is going to be creating. So that model, it has to have the following. It has to have a name, it has to have a return type, it has to have the number of parameters, if there are any, and it has, I don't need to know what parameters, the name that you use, but I need to give the data type of each parameter. So those are the three things that we're going to have: a name, a return type, and then the number of parameters, but the number of parameters is going to be determined by the data type of each parameter. I'm going to give you an example right now using the same programs that we open right now. I'm going to open the last one. So we have here our deep, deeper, and so forth. So I'm going to remove all that from here. Well, let's start with deep first. So instead of having here the whole thing, I'm going to remove this, the body. I don't need the body. Here I have just void deep. And let's suppose that this is another area. Another area can be another device, storage device. Let me put here another storage area. And I'm going to paste everything here. So now the linker, when it reads this line, it knows that it's a prototype. Prototypes, they do need to end with a semicolon. So I have here my return type, my name, and my list here of parameters. Right now it's empty because I don't need any parameters. So as you can see, it's, in this case, it's going to be exactly the same as the header. Trust me on this, okay? So let's suppose that I have some parameters here, x, this one is saying I'm going to be needing 2 parameters, so whoever calls dip is going to be sending 2 parameters. So in the prototype, I don't need to put x and y, because remember, this is going to be coded by another programmer. I don't know what names that programmer is going to be using for the variables. These are 2 are variables, right? But I do know that I'm going to be sending an int and a double. So that I do know. I don't know about the names because this is a different programmer. I asked Ivan to use 2 specific names, and I know that Ivan is not going to use the names that I indicate because he likes some other names. So instead of going into that problem, I am the one that is doing main, so I have also to do my prototype, and I'm going to be doing my prototype doing this. The name of the function that my programmer that is assisting me in this routine, in this function, is going to follow, because that it has something that we cannot change. So we have to agree on the name, deep. The return type, we need to agree on that. And then the parameter list, I just need to say the data type. The other programmer has to decide the names that is going to be using for the variables. So here I have 2 values that are going to be used. One is going to be an int and another one is going to be a double. So I completed the requirement here. The compiler must know the following about the function before it's called. The name, I'm giving it the name. There it is. I'm giving it the return type. It's void. And I'm giving it the number of parameters by using the data types. How many parameters do we have here? 2. One is an int and the other one is a double. So this is a prototype. So a function prototype, it's a way to notify the compiler about the function before a call is made. The prototype sometimes is also called a function declaration. Some notes. Place prototypes near the top of the program. They always have to be after the includes. If you do not use a prototype, then you have to use the full function definition. When using prototype, function definitions can be placed in any order in the source file. And of course, traditionally, main is placed first. So we have the prototypes, and then we're going to be placing main. Questions? Okay, if I'm going to be doing the prototypes for the other ones, for deeper, I'm going to remove this again. Deeper, it doesn't have any parameters, so it's going to be, I'm going to leave it empty. This is a prototype, so I'm going to be ending the line with a semicolon. And then here in another storage area, I'm going to have my function, deeper. The same thing for, let's see, which is the deeper. I'm going to remove everything. And then in another storage area, I'm going to have my deeper. Let me just remove all these comments so that we don't get confused with all this. Yes, thank you. So here we have okay, let's suppose that deep, deeper, and deeper are my 3 programs. My gross pay, my deductions, and my printing. So remember I told you they hire me to do this payroll program, but I'm going to have my 3 programmers that are going to help me. So I'm going to be doing my prototypes, and then I'm going to be doing my main. I don't know what this program deep, where's deep? Right here. This function is going to be doing. I know what it's going to be doing, but not the actual statements, because that's what my programmer Ivan is doing for me. But I'm telling my programmer, okay, you're going to be receiving an int and a double. 2 parameters. So you use that. So when it's done, then the program is going to give me all this. Then I have another programmer that is going to be doing the deeper, which is going to be where we're going to be doing the calculation for the deductions. I'm not giving anything. And then when it's done, here is the function itself that programmer created for this project. And I have a third function that is called deeper. And again, I have a third programmer that is going to be doing that. But I don't have that information yet. So I just put my prototype here. 1, 2, 3. When they are done, they are going to give me everything, and we're going to put it there in my server, in my hard disk, and now I can work with it. And I can integrate everything. Okay? Questions? No questions? Are we going to be using what? I'm sorry? We're going to be doing prototypes. We're going to be integrating prototypes in our program.